Science is a work in progress. As we learn new things about this amazing universe in which we live, we constantly revise our understanding of it. This can lead to some scientific concepts becoming out of date, or even shown to be flat wrong, such as the proverbial canals on Mars. And sometimes the misconceptions were never right in the first place. Yet sometimes these misconceptions can persist for years or decades, despite being in error. And new misconceptions arise often. My guest today studies these misconceptions about space and has authored a book correcting many of the most common ones.
You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Bob King. Bob King has enjoyed the night sky and astronomy since childhood and shares that passion through public observing, speaking and writing. He works as a photo editor at the Dulles News Tribune and specializes in capturing moments and stories about people. His books include Night Sky with the Naked Eye and Wonders of the Night Sky You Must See Before You Die. He also writes for Sky and Telescope and Universe Today, as well as frequently on his astronomy blog called Astro Bob, and teaches community education astronomy at his local planetarium.
Bob King, welcome to the program.
Well, thank you. Very happy to be here.
Now, Bob, you wrote a really interesting book, Urban Legends from Space, The Biggest Myths About Space Demystified. What was your motivation for writing this? Were you just wanting to sort of clear things up for people that have heard all of these misconceptions over the years?
Yes, I would say that's it in a nutshell. Science communication is at the foundation of it. It's just trying to present certain topics, especially ones that people have dabbled in, maybe have seen online, read a little bit about, maybe seen a YouTube video, and sometimes they're a little sketchy, some of those things. And so what I try to do in the book as well as in my blog is just to try to communicate the science behind things so that it's more transparent and obvious. So yeah, it's to clear up some crazy things sometimes that people talk about.
What is the craziest misconception you've come across?
Oh my gosh. Well, the most popular one has to be UFOs, right? And after that, or maybe tied for first place, is that we never went to the moon. That is popular, thankfully, among just a minority of people. But those do come up. And in the book, what I try to do is offer people ways of not leaping to the grandest conclusions. In other words, let's take the case of the UFO. If somebody sees an unusual light in the sky and takes a picture of it or a video of it with their phone and sends it to me, and it's an out-of-focus picture of Venus, sometimes, and it's strictly out of ignorance, people don't know because they're not normally looking at the sky, but suddenly they notice something, and it becomes an amazing thing that they've never seen before. And I've noticed that people will often jump to the most amazing conclusion. They'll take this enormous leap and say, I think it's a UFO, and start to convince themselves that it's an unidentified object. And what I try to do is explain, before you go that far, let's consider some other natural possibilities. It could be this or that. And so the book has things in it like that where you might want to just stop for a minute and consider. And that's, in the book I try to be helpful like that, sort of educate and communicate the science behind things.
So with the UFOs, I myself saw people have a UFO experience once.
Yeah.
And I knew what it was. It was a Chinese lantern.
Oh, cool.
And to this day, and this was back when those things were really first starting to, you'd see them in the sky on holidays and things like that. And back then, nobody really knew what they were, or drones, for that matter, sort of fell in that category too. And I've actually noticed over the years that UFO sighting, which they're still convinced it was one, has morphed into something much greater than what I saw,
Oh, yeah.
So the trick of memory.
You mean the very thing that you saw has morphed into
Yes.
something more extravagant?
More extravagant. It was moving and zipping around now when, in fact, it was not.
Yeah.
So you also wonder about the reliability of human memory in some of these things. And of course, well, for an example in your book, you point out the Nemesis Star and how some people claim to see it by taking a photograph of the cell phone with the cell phone of the sun, and you see a second sun in there. But it's really just a reflection internally in the camera of the cell phone.
Exactly, yeah. But again, people don't know that. They're not familiar with internal reflections in lenses. You may not have noticed it, and then they see it for the first time, and they're like, wait a minute, I think I've got something here. That's really perfectly understandable. But in the book, what I try to do is accept that, accept the understanding. Oh, I get it, that's what you see. But by the way, here's a way to prove that it's not a real thing. Take your phone, move it to the other side of the sun, and you'll see the same thing there. Move it, there's a little thing in there about how to show that it really is just a reflection. And I even have my own picture of one of those so-called second suns that I created right on the spot here in my front yard using my cell phone. But I think things morph too, partly because it's like a game of telephone where people pass on a story and then it becomes more amazing each time it gets passed on. But it often starts with something in nature, like what you saw, or something man-made in the case of the lantern. I can think we're familiar with things that happen kind of horizontally in front of us on the planet as we go through our lives, looking at computers, driving through traffic. But we lose our perspective, understandably, when we stare up into the heavens. A familiar misunderstanding is how close a meteor is, for instance. We look at fireworks shows, and when a firework explodes on the 4th of July, we know that is pretty close to us. We can feel the boom, and it's a bright sparkle. When people see a bright meteor, and they see it pass over behind a house in the distance, it's natural to assume that it's actually nearby, that it's like just over the hill. And this is a very common misunderstanding, when in fact, that meteor, as long as you can see it, is approximately, or at least 50, 60 to 70 miles high and probably hundreds of miles horizontally in the distance. So again, we lack that sort of perception when it comes to the sky because we're not familiar with the sky. And many of the things that I talk about in the book have to do with the sky because that's my specialty. That's what I love so much. I love looking up in the night sky and communicating what I see and explaining it, hopefully in a way that's understandable for people. And an attempt also to dispel myths or misconceptions, to educate. Part of that is to encourage people to really use their senses and to get into being good observers of nature. When you're a really good observer, you look at things closely, you start to see how nature works and anticipate things. Then when somebody shows you a picture of a second sun or some other bizarre phenomenon, like a ring around the sun with big bright spots on it, you can go, oh gosh, yes, I've seen that before. That's a halo, and those bright spots on either sides are sundogs. It's not an alien ring, or it's not caused by a nuclear explosion, or whatever it happens to be, or the approach of Nemesis. So I think we have it within us to depend upon our senses as good observers, coupled with a sense of critical thinking, I think, to go out into the world and to not believe the most fantastic claims right off, but to bite it back a little bit and look for something look for a natural explanation first.
Now, your book starts by going into the scientific method and the importance of that, which dovetails with what you're saying. Mm-hmm. Give us an overview of the thought process of the scientific method. I think most of my audience already knows what that is, but it's probably a good idea to explain how to think about things.
Oh, of course. I think it's just one of the most beautiful tools that's ever been crafted by humanity is the scientific method, and it's going to save us from a lot of trouble. Of course, it's gotten us into trouble, but, we use knowledge in good and bad ways. But the method begins, I guess, with a hypothesis. You have a hunch. You think, I've been observing this for a while, and I wonder if these two things are connected. And then you perform some kind of an experiment, and see if you can reach a conclusion or if what your hypothesis predicts actually happens. Sometimes you'll have an idea, do the experiment, And no matter how you do the experiment in as many different ways as possible, the outcome just isn't what you expected. So you have to revise your hypothesis. But if what your claim is starts to make sense and you have actual data behind it, and especially when it comes to physics, if it's mathematics, a good, strong mathematical underpinning, then you've got something. Maybe your hypothesis has some truth to it. So then you write up your paper, put your data in, and you send it off into the world. And of course, that can be a crushing experience, because one of the greatest things about science is that your fellow scientists will want to rip the shreds out of it to see if it's actually true, because you're making a new claim. And so two things happen there. It goes through a peer review process before publication. And this can really, many papers are knocked out from being published because during peer review, the research is revealed to not be adequate, and it's sent back. But if it is published, then other scientists will look at it carefully and see if they can either prove you right or wrong. If they do a similar experiment and get similar results, then that really strengthens your hypothesis, and you can start going forward then with expanding on that. So it's just it's a way of gathering information and verifying it as best you can, getting it reviewed, and then suffering as other scientists dig through it and tear it apart in an attempt to disprove you or prove you right.
Now, you mentioned, and this is a good example of this, Nemesis. That actually started with a legitimate hypothesis, I believe by Dr. Richard Muller back in the 1980s.
It did.
But it was never seen. So that's an example of where it didn't really end up being reality, yet it still ended up out there as a kind of meme.
A meme, yes, it really did. And that was exactly a legitimate hypothesis, that there seems to be a periodicity in these extinction events across the eons. And it perhaps could be explained by a tiny star in orbit around the sun that periodically comes close to this giant cloud of comets called the Oort cloud and knocks them free. And then they come pelting the planet, which causes the extinction. A large but reasonable hypothesis, but despite all of the attempts to try to find Nemesis, the wonderful nickname for this object, it was never found. And it likely does not exist. But exactly as you said, John, it remains in the public consciousness. And sometimes it morphs, kind of like your Chinese lantern again, into something that it was never intended to be, an actual object on its way to striking the Earth. So, for which we have no evidence.
That brings up another possibility too, is that there is a killer asteroid coming towards us, and that someday it's going to hit us or whatever in 2050 or something like that. Whereas the actual chances are almost zero of that happening, I think, with that particular asteroid.
Right, Apophis you might be referring to.
Yes, I think so, yeah.
Mm-hmm.
Now, the thing is, though, we can get hit by an asteroid, just not likely from anyone we know about currently. So the misconception, once again, has a basis in truth that, ask a dinosaur. It does happen occasionally, but it only happens very occasionally.
Yeah, I mean, I think it's inevitable that the Earth will be struck sometime again in the future, because we have been hit in the past. And I'll tell you why I'm convinced it's going to happen, because back in 1994, there was a comet called Shoemaker-Levy that orbited Jupiter, broke into pieces, and each of these pieces rained down on the planet, struck its atmosphere. Jupiter, there is no surface, it's just atmospheric clouds. So it struck each piece, one after another, as Jupiter rotated. I had here at my house my telescope, and I pointed it at Jupiter during this whole event. And unbelievably, I saw dark spots on the planet, as did a lot of other amateur astronomers. So before my eyes, I saw physical proof that asteroids and comets really do hit planets, and that's just in my short lifetime. Sometimes when people ask me, what's the coolest thing you've ever seen in the night sky? And I'll tell them, that's it, if I had to pick one. And that really impressed upon me the realization that these things do happen. Hence, the reason why there are so many asteroid surveys, well, there are not so many, I guess. There always could be more, but there are a number of asteroid surveys in progress where astronomers use robotic telescopes to sweep the night sky looking for any fast-moving object, and then they calculate an orbit for it as quickly as possible. Often that orbit is rough, and it might indicate in the beginning that there's a 1 in 2,000 chance of hitting the Earth in the next 100 years, which is significant. But over time, when the orbit is refined, we make many more observations of that asteroid or comet, that number usually drops very close to zero. And at the moment, there are no asteroids we know about that are going to strike the Earth anytime the next 100 years plus. There's not a particular object you can point to and say, yep, 300 years from now, that's going to hit the Earth. There's probabilities, but so far very small for everything we know about. What's fascinating, though, is that every day we are struck by little pieces of asteroids, little mini asteroids, right? The Earth is pelted by meteorites, or meteoroids, and then when they make it through the atmosphere, they can sometimes land on the ground as meteorites. So we are being bombarded, but most of this material is so small, it's harmless. The larger you go up, the bigger the scale, the greater the more remote the probability it's going to happen. But at the same time, the greater the devastation.
Indeed. And I mean, just off the top of my head, over the last century, we had Tunguska, Chelyabinsk, which shattered many windows across Russia.
Yes.
And let's see, there was also one, I remember, Sokoty-Alinsk, which dropped an iron, bunch of fragments of an iron meteorite on a mountainside in the 40s in Russia as well.
Yeah, tons and tons, and made a bunch of craters as well. The Sokoty-Alinsk, in Russia, in 1947.
Yeah, and there's actually even a commemorative stamp that the Soviet Union printed of that meteorite hitting, which brings us to another misconception, that meteorites are hot when they hit the ground.
Right.
They're
Yeah.
Explain what really happens.
I know. I will never live long enough to see that go away. That belief. There's still over the internet. There'll be over in India. There'll be a picture of a burned down building and a hole in the ground, and the fireball caused this, and so on. But in fact, most meteorites, some can be warm to the touch, but these things are out in space. And so they are relatively cold. They move through the atmosphere very rapidly. In a very short time, less than a minute, they go from outer space to being on the ground. Now, the passage through the atmosphere is rapid, right? They can be traveling at 50,000 miles an hour. Naturally, they do heat up, but it's extremely fast. So the outer part of that meteorite, outer millimeter or two, is often toasted, so it develops a fusion crust. But the interior of the meteorite maintains the cold temperature, so that when it falls, if you go and touch it, there was just a fall last winter in Cuba, and it was happening right in daytime. People went up and picked up these meteorites, and they were cold to the touch. And that's because although the outside is baked a millimeter or two, remember it's a rock, the inside is still cold. And so when you pick it up, you feel cold. I think the misconception of heat has to do with the appearance of a meteor. It looks like it's on fire. And naturally, we are careful if something falls that looks like it's on fire and we approach it, we might think it's going to be very hot. And I honestly believe that we can convince ourselves that it is hot. And sometimes cold can feel like something being hot, too. So I think it's kind of a mixture of perception. But that glow you see in the sky is not fire at all. Even though a meteor looks like it's on fire, that glow is actually nothing more of an ionized air. That's the energy of the little particle's motion, the chunk of rock. Energy is being transferred to the air molecules, which then release the energy as light. And that's the brilliant meteor you see. There's really no fire. The meteorite, what's going to become a meteorite, actually drops It hits the atmosphere at 55 miles high. And then I can't remember the exact height, but many, many thousands of feet up, it starts its dark flight, where it plummets to the ground and it does not ionize the air. You can't even see the thing, and it cools rapidly, too, during the plummet. So, yeah, I think we just need to have more meteorites falling and people going out to touch them to get a better sense of how cold they really are. But they fall so infrequently where there are people around to see them and then run up to them and touch them.
Occasionally, though, things happen. Do you remember the, what was it, Peekskill, New York meteorite that hit a car?
Oh, my gosh, Peekskill, yes.
Yeah.
That was so great.
Hit a car. And
it was filmed during the football game. The fireball splitting apart into pieces, and then it slammed right through the back end of the car. And the car became as famous as the meteorite. Somebody paid a ton of money for that car.
Yeah, as I recall, it's a museum piece now.
Yes, it is.
You can get hit by a meteorite. I remember also there was a case of a lady in the 1950s that it came through a roof and hit her in the hip. And
yes. And
then of course the famous Martian meteorite Nakhla, the story about it, one of them killing a dog.
The Nakhla meteorite in Egypt back in 19 whatever, way back over 100 years ago.
Something like that.
Yeah.
That brings up an interesting phenomenon in and of itself.
Yeah.
Have you ever heard of the Ensisheim meteorite?
I sure have. As a matter of fact, I have a small slice of it.
So do I. And I should, by the way, disclose I'm an amateur astronomer too, so I also saw Jupiter get hit in my senior year in high school through a Coulter Optical Odyssey 8 telescope.
Oh, that's awesome. Wonderful. What did you think? Were you excited?
I was astonished. But I would actually, to be honest with you, back in those days, I have one thing happened that I would rank higher as far as excitement for me, and it was seeing Comet Hale-Bopp. I think that was the one that, because it was just clearly, you weren't looking at it through a telescope. You could see that comet with your naked eye clearly and photograph it and do all that stuff. So that one was the most amazing for me, mainly because Halley's Comet years before had been so disappointing.
Yeah, I know. Hale-Bopp was just fantastic. You just walked out the house and looked out. Oh, there it is, hanging over in the northern sky. Yep. What a beautiful object. That brings up another really interesting misconception that just happened on my blog this week. And that was, there was a new comet that's out. You probably heard of it, Comet Swan, which is going to become a naked eye comet, or actually it is a naked eye comet now, but it's going to be visible here in the northern latitudes come the middle of May through the end of May. I posted a picture of this comet that someone had taken on April 18th, and somebody wrote in and said, that's old news. Looks like I have to wait for the next comet. And I thought, because it was April 30th when he wrote that, and I thought, well, why is that old news? And then it hit me. Comets, to a lot of people, look exactly like meteors. And this person thought that was just kind of a one-shot show. It was there and gone. So it gave me an opportunity to explain, no, comets are far away, move slowly, they're beyond the atmosphere, they look like meteors, but totally different things.
Indeed, though, they often cause meteor showers, just in a delayed action.
They are related. Right, definitely related. And, it's fun that they are related, even though they're very far apart from one another. But yeah, the little bits of comets that spalled off as they approached the sun, sort of boiled off as they vaporized, those pieces do form a stream of debris behind the comet. And then when the Earth passes through that stream, whoop, I always liken it to either one of two things, going through a cloud of bugs in your car or driving through a snowstorm at night. And those meteors stream, those little comet bits stream and slam your windshield, or snowflakes hit your windshield. Well, the Earth goes through the stream the way a car goes through the snow. And instead of snowflakes or bugs, those little fragments from the comet hit Earth's atmospheric windshield and burn up, and that's what creates a meteor shower.
Is it possible, as a comet passes by and is spraying out this material that eventually becomes meteors, could it actually, say a gas jet or something from the nucleus, could it fire off a rock that's big enough to make it to the surface of the Earth? Have we ever seen anything like that? Or is it just doesn't happen unless it actually gets hit physically or something like that?
Boy, it would have to be some extraordinary circumstance, wouldn't it? And it would have to be very close to the Earth for that hit to happen. I have never heard of it. As a matter of fact, we aren't even sure we have any material from comets. There are some types of meteorites that appear to be cometary. You know, these black, fragile, carbonaceous chondrites, they're called. But there's no definitive, we don't have a single meteorite where we can say, yep, that's definitely from a comet. So it's quite rare. All the meteorites that we have in our collections are from asteroids, at least to our current knowledge. So it must be really rare for that to happen with a comet. But I suppose anything is possible, you know, close enough to the Earth, the right trajectory, it might happen, given the fullness of time, of course.
Now, to switch gears, another very persistent misconception that I've heard is that Jupiter is a failed star.
Yeah.
It is not. Tell us about that.
Yeah, it is. That goes right along with the sun. The sun will one day go nova. I often hear that. The sun will explode as a nova, which also won't happen. But Jupiter just doesn't possess enough mass to become a star. You got to have a lot of stuff to be a star, so that gravity can crush that stuff into a very hot little core that initiates the fusion of hydrogen atoms into helium. And that's really the stellar fire, so to speak, nuclear fusion, and that causes a star to light up and give light and heat. Jupiter is, if you took 80 Jupiters and you crushed them all into a nice compact ball the way you would a snowball, really crush it, 80 Jupiters would be enough to create a small star under the right circumstances. So no, even though Jupiter is massive, it possesses too little mass to become a star.
I guess that could be said if you took all of the material in the solar system, you still wouldn't be there, right?
Right, because the next most massive planet is Saturn, and then Uranus, there's hardly enough. You'd need 80 planets as big as Jupiter, or as massive as that planet, to become a star. So yeah, there's not enough material around for that to happen. We are unusual in that regard that we only have one sun. There are, as an amateur astronomer, you know that when you point a telescope at the sky, a great many stars, I think it's more than half, are actually double or multiple. So our sun was apparently born all by itself, and the remaining matter that did not go into building the sun ultimately settled down to form the disk of the solar system, the plane of the planets, and all of our wonderful planets that we look at in the night sky. And there's a bunch of them out right now. They're just beautiful. Venus in the west, and if you get up in the morning sky, you can see in the southeast, in this order, you can see Jupiter, very bright. To the left of it is Saturn, and much further to the left is Mars. So we have 4 planets out presently.
Yeah, and Venus is looking particularly bright, I noticed.
Yes, it is. Which
makes you wonder how many UFO sightings are happening right now.
I just had one. I'm sure there are a whole lot, John. I just had someone, I mentioned the comet thing happening on the blog, but I had someone also send me video frames of a bright, out-of-focus object. And I looked at it, and I looked at the date, and I took that date and I put it into a software program, Stellarium, which simulates the night sky. And wouldn't you know, but on that very date, Venus was out in the western sky. And the way the person described the object, I realized it was just the camera being unable to focus Venus. And there was a piece of dust in the camera lens, and so it looked like a little splinter inside that bright disk. The person who sent it to me thought that they saw Venus splitting, and I wrote back and explained, nope, that's out of focus, and what you're seeing is dirt inside the camera lens. And we had a nice conversation, and she was satisfied with the explanation.
Now, invariably, though, the UFO people are going to ask me this. They're going to ask about the recent declassified government footage of unidentified flying objects.
Oh, you mean the 2004 Navy pilot thing? Yeah. Mm-hmm.
I mean, how does one go about analyzing that? What is the process of elimination to try and figure out exactly what that is?
Well, I think, I wrote about this very thing in the book, and I think it's perfectly fine to say you don't know what something is. It looked like such and such. It looked like it was moving rapidly. But again, to make the leap that it's an alien spacecraft, that's an enormous leap for which you would need an enormous amount of proof. But to recognize that it's unknown is fine. I love unknowns because then we can start looking at more of them. And I'm really happy with what the Navy did, which is to encourage their people to report these things. I think the more information you get and the more deeply you look at it, the more likely you're going to come up with a prosaic explanation. Just the same way as Venus that I just talked about, Venus and the camera out of focus. There's definitely an explanation, but on the surface of it, it looks profound. And maybe it is profound in some other way, but again, the leap is too large to go to a UFO, even though it's much more exciting if something might be a UFO. I was just walking in the woods yesterday, and I thought, gee, if a squirrel crossed my path, I would not go to my friend and say, hey, I was in the woods the other day, and I saw a squirrel pass right in front of me. They would be like, yeah, that happens all the time. But if I said a moose crossed my path, the heads would go back and be like, really? That's incredible. So I think there's something about the storytelling value of considering that it might be a UFO that's just a lot juicier than a squirrel, so to speak.
It is, but even still, and this is something that I think a lot of people sort of forget. There was a paper last year written by Jason Wright of Pennsylvania State University where he laid out the case that it is possible, marginally so, that Earth might have had a prior technological civilization on it that has just been erased by geologic time, which means that if you do see a UFO and it turns out to be something very strange, you still can't ever say it's alien because you could never eliminate the fact that it didn't come from here in the past.
Oh, my gosh. Well, I mean, again, you need evidence for things. If there's evidence for that of an ancient technological civilization, then man, I want to see it. I want to read those papers. I want to see those papers peer reviewed and all of that put out. But until that happens, I think it's fine to surmise. That's how you begin sometimes gathering new knowledge. You just put out a hypothesis and you try to see if it might be true. You see if it sticks to the wall. But by gosh, if it doesn't stick to the wall, then I think you got to be honest with yourself and say, nope, that didn't work. Maybe I'll abandon that idea and try something else. But there are sometimes people will just stick to it against all odds and push an idea that is false in so many ways, and yet it's a pet idea of theirs, and they believe it, and they promulgate it. And to me, that's where you need critical thinking skills and good observational skills to see the difference between that and something that's real science. So I'll always ask people, I say, well, go to Google Scholar. I put that in the book as a place where they can check on a paper about the topic. And always look at the source of the information. Is it an actual scientist that did this research? Or is it, not to defame any profession, is it done by a car dealer or something, So the source is really important, and then looking up the original information counts a lot. So I believe in experts, too. I think what's happened kind of nowadays is that the Internet has it's a chance for everybody to kind of get their voice out there, which is wonderful. But sometimes people pretend to be experts on some topics when they really aren't. And then they make fun of those who actually have the real knowledge, who are experts. So I like to see someone who's an actual scientist talking about the research. And they can speculate, too, so long as I know that the context is speculation. That's important.
Well, I think a good example of this that has reared its ugly head on the internet a lot lately is flat Earth.
Yeah.
Now, here you have a concept that one could disprove on their own without even asking a scientist. You could just go out and prove it by multiple ways on your own. Yet people persist in believing it. And I used to think that these types of people were just, trolling everyone. But no, there are people that really believe the Earth is flat. And that, things like, ships disappearing gradually, on the horizon,
Yeah.
that doesn't work for them. And it's interesting because it becomes more of a religion at some point than an actual worldview.
Yeah, I think it does become, in that really peculiar instance, isn't it, that it becomes a matter of faith or belonging to a particular sort of ideology. And whatever the gain is there, to believe that. Maybe it's just maybe they don't like the man, And so by believing what the man doesn't believe, then you get a sense of, I'm looking at the world my own way. I'm grasping it the way I want to. But that can really lead to your downfall, particularly, when I think of the vaccine thing. People that think that vaccinations are bad and what it can do. You can die if you don't get vaccinated. It can be your belief, but you can die, or potentially you can infect someone else who then might die. So they can have real consequences. The flat earth thing, as far as I could tell, it doesn't have any actual consequences. It's just odd that people insist on it. I think it's not just the ship thing, too. Any orbiting object like the space station, if it was going around a flat earth, it would crash into the ground. And there's so many different ways you can disprove that. I spent a chapter in the book talking about the flat earth. And again, but people who aren't educated in science so much, or maybe they were, but they've forgotten. We have busy lives, kids to raise. I try to provide examples and reasoning so that when they do see some things like this online, they don't scratch their chins and go, there's some good ideas there about the flat earth. Maybe I should check that out. But again, there are explanations for that. We've been through the whole flat earth thing. That happened thousands of years ago. So my easiest one is I'll show people the planets. And the planets are spherical, and you can see that. And I say, well, would you want the Earth to be flat compared to these lovely planets? No, we're all part of the same family.
Well, in a lunar eclipse,
Lunar eclipse is one, yeah. I think it's odd because back in the days before there was a lot of scientific reasoning, if you looked out your window or took a long walk or journeyed on a boat or whatever, the Earth does look flat. And that's maybe the basis for the belief in the first place. But all you've got to do is get above it high enough, and the Earth is a sphere. And there's so many great and beautiful photographs of that online and in books that are available to anyone to see.
Now, one thing I wanted to discuss with you, one last misconception in our little exploration of these, is something that's going to become, I think, very interesting and important with the activities of SpaceX wanting to found a Mars colony, and of course NASA wanting to go to Mars, and all of these things. The Martian, by Andy Weir, the movie anyway, shows that a giant dust storm on Mars and destroying everything and doing all that sort of thing. That's not going to happen. Mars, as far as its winds, isn't that dangerous. Can you go into that?
Yeah, I love The Martian, by the way. I've read the book. And I also saw the movie, too, and I thought Matt Damon did a great job. Mars, the winds, the way they show it in the movie is for dramatic effect, I'm sure. But although Mars can have powerful winds, something like 60, 70 miles an hour, which is a good stormy, windy day here on the planet Earth, there is a big difference, though, between a Martian wind and an earthly wind, and that is how much wind there is, how much air there is on Mars. Mars has like 1% of the density of the air that the Earth has. It's extremely thin. So when that thin air blows at 60 miles an hour, that's equivalent to about an 8-mile-an-hour wind here on the Earth. And if it was an 8-mile-an-hour wind, you'd go out and think it was just a perfectly fine day. Mars has a lot of dust, though. There's a lot of fine material, so those winds are strong enough to lift that material up into the air. And there really are dust storms on Mars. There's no question about it. We see them in our telescopes. But the physical power of those dust storms does not match a 60, 70 mile an hour wind on the Earth. It's far less because the air is so thin on the planet.
These misconceptions, they still are cropping up. They get created to this day.
Every day.
And I would use an example would be Oumuamua, where it's sort of morphing into this alien object, whereas it really is probably an asteroid or something, some kind of debris, natural debris. But again, as it propagates across the internet, it's becoming increasingly alien. So these misconceptions continue to arise. Do you see a time where that's going to stop, where we could actually sort of be, what would be a good word? Do you see us moving in a direction where misconceptions will become less and less, or increase?
That is like a tremendous question. I don't think that people ultimately will change. The great mass of us, humanity. I think that there will always be things that people believe in that to another group of people make no sense at all. We are a wild, diverse kind of species, especially when it comes to our beliefs, our thoughts. My hope is that science gets us through all of this because it is a repeatable, rational activity. I can do it here, somebody else can repeat it. Science looks at data, looks at nature closely, and tries to weave together the little disparate bits into a grand story that makes sense. And I hope we can be guided by this story. I think the frustration with science is that it is continually changing. It's always being updated. And I think people, us, we have a natural propensity for black and white. We like things to be this or that. It's a lot easier to deal with it if it's this or that. Whereas science is always kind of wiggling around the middle in the gray area, which can be frustrating. But to me, that's the nature of reality. We are always in the process of learning from nature. So I think as long as we are willing to learn from nature, and the more of us, the better, I'm happy at that prospect. Whether those numbers will increase, I can't say. One of the things that really heartens me, John, though, recently, is having to do with the COVID-19 virus. And I see a lot of people, like the governors and various mayors and just people here in the neighborhood, talking about, well, we're not going to act on such and such until we get the science. I see there's a renewed interest or respect, I guess, for the fact that when it comes right down to it, I'll take the science rather than the speculation. So I think that, at least for the present time, we're still grounded in science as a species in terms of our interpretations of things and how to make cures and protect ourselves from asteroids. But we are diverse, and so I make no guarantees. I know nothing about the future. Can only hope for the best.
Can only hope for the best.
Yeah. What else? How else can you go through life, right?
Well, if you hope for the best, life tends to be better anyway.
Yeah. I mean, and the thing is, that's what you're doing here. That's what I'm doing. We're both doing the same thing, and that is just trying to communicate basic science. Listening is always the key. Very important to listen. Long ago, I used to, maybe not so long ago, I used to think, no, you're wrong. That can't be true. Now I listen because I'm trying to find out why someone believes or thinks that way. And then from there, I might try to get in a little information. Oh, did you know this? Did you know that? Do it in a more gentle fashion, I guess. Because knowledge is always needed. We always need that light, that comes from information and clarity. So, but the basis for our beliefs is often, it makes sense based upon our own life experience. We just need fresh information. That's all.
And there's going to be no shortage of that, especially in regards to astronomy. We have a lot of interesting new instruments coming online, and we're going to enter what I think is a golden age of astronomy with all of these, James Webb Telescope and all of the exploration of the solar system. So the fun is just beginning.
Oh, I know it. It's just tremendous. And it heartens me. I do community ed astronomy here in Duluth. So I teach over at the planetarium, although not lately because of the COVID-19 thing. But I am amazed at how many people come to class quarter after quarter, year after year. There is a natural interest in science by the public. People are fascinated by it because it's grounded in our curiosity about the universe. Who doesn't go outside, look up, and wonder? Everybody asks me, do you think there's life up there when we're outside? But I see this tremendous interest in science, and I think the key here is to just give good information and keep presenting the science, because it feeds our natural interest about the world. We're naturally curious. We want to know, and that's a good thing. That, to me, is what's going to keep humanity around and make for a good world, that curiosity.
And we've never lost it.
No, until that curiosity led us to the understanding that there are asteroids out there that can threaten the entire planet. And now we have surveys, like we talked earlier on in the interview. And potentially a telescope will be built that will be sent in orbit that will look at another part of the sky in the direction of the sun where we can't presently see asteroids coming from. So that will help to saturate our effort. And that, hopefully, will be able to preserve our species and many of those on the planet through these efforts. Yeah, I believe in the good, for sure.
All right, Bob, your book, Urban Legends from Space, The Biggest Myths About Space Demystified. Where can everybody get that book?
That book can be found. You can get it at Barnes & Noble. You can get it at Barnes & Noble website, of course, and Amazon. It's up there as well, and at indiebooks.com. So basically, you can get it anywhere online, Amazon and so on. And then you can thumb through it, if you like, at a Barnes & Noble. I also do a blog, a regular blog about the night sky called Astrobob. And I regularly update it with things that people can look at, naked eye or binoculars, occasionally a telescope. So if people want to Google that, if they have any questions, they can do that. I'd be happy to answer. I try to answer all the questions that come my way.
Links to all will be in the description below. Thanks for joining us today, Bob. It was a great discussion.
Yeah, I thought so too, John, and thank you so much for having me. It was really a pleasure.
John, why have you written green cheese on your moon globe?
What, haven't you ever heard that misconception that the moon is made out of green cheese?
But it's not, John. It's made out of rock.
I know that. I just want it to be made out of cheese. Pizza would be even better.
Oh dear. Not the pizza hypothesis again.
What? It works for everything. What's inside of the event horizon of a black hole? Pizza. See, even the possum gets it. Now I'm hungry. And on that note, joining us next week is Stephen Wolfram for a chat about cosmology. See you then.